And I think a great way to explain, at least in my mind, why I love machine learning so much is to explain how much of a nerd I am. When I was 15 years old, I wrote a game. You can imagine how popular I was. I wrote a game in high school. It was a baseball game. I spent 6 months developing this thing. And it was full of, if you're a baseball pitcher, you throw the ball, and depending on how you throw it, how fast you go, how fast the ball goes, the batter swings and the ball flies one way or another. I showed it to my friends, and they said, get a life. But then they came back and said, actually, this is pretty good, but it could be better if you do this. If you add a variable that it's raining outside, or maybe you're at a higher altitude, the ball travels a different way. So I said, that's good feedback, and I went back and I diligently changed my program. I added those additional variables, and the game got better. And pretty much I spent the next couple of years doing that. So that basic way of developing software is how software has been developed since the beginning of time, for 40 plus years. And it is not super productive. It's not super, when you're talking about a world of 7 billion people and only 20 million developers, it's not a sustainable model, right? Software developers are the new inventors of the new world. So machine learning changes the paradigm. I could actually walk through, in the 12 minutes I have left, basically the point of my session is how Google does AI, or how Google does machine learning. And the crux of what I wanted to walk through were a handful of examples of how Google uses machine learning internally, how we develop products for our customers, and how it changes the paradigm for programmers, for developers. So when I was a developer, it's full of, the way you develop is full of if-then-else statements, right? Hard-coded rules, heuristics. And what machine learning does, as you learned in earlier sessions, is it changes the way software is developed such that it's a self-learning system, a self-improving system. So you don't need to sit and work on every single line of code, create every single rule. And for a company like Google, this is really powerful, right? We have 7 products that have over 1 billion regular users, and codifying rules for those products with 1 billion users is simply not sustainable. So for us, machine learning makes it possible to serve our customers better. But since we have 15 minutes, I'm just going to go ahead and tell stories about machine learning at Google. So how many people here use Google Photos? Can't see. Okay, it's a fantastic product, right? It's practically magical. I've uploaded 30,000 images myself. And what's great about Photos is it can identify what and who's in a photo, going back, to all of your photos in an incredible amount of detail. So if you have a picture of a painting of a picture that has the Eiffel Tower in it somewhere in the back, and you type in Eiffel Tower, it can find that image of the Eiffel Tower. So Google Photos has been trained with machine learning. Search, right? Google Search, what we're most known for. We have an algorithm called RankBrain, which is one of the 150 or so signals that gives you the best. Here we go. I see my slide. So as I was saying, this changes the paradigm of how software is developed, right? This is a fundamental shift. Rather than, again, doing if-then-else statements, this is a way to create a system that's a closed loop where it can improve itself, where in the baseball game that I built before, it can take in these new variables and get better and better and better. And this is what we've developed across our 7 products with 1 billion users. It's a core of how we develop software now. All right, I'm going to have to run back and forth. So as proof of that, we have now 4,000 algorithms inside of Google going across all the products that you would think that you know about Google. So ranging from mail through search, through Waymo. This is now core to how we develop and deliver our services. So search, again, RankBrain, the number 3 signal in all of how the search results come up is trained on a machine learning model. So it understands not just what you're asking for, but it understands, to a large extent, what other people were looking for, and it improves over time. The more data you have, the better results you have. So this is Google's been in the business of translations for a long time. Translation hasn't been fantastic. We applied we applied the machine learning models against our translation engine and improved translation to where now you're really kind of right on the cusp of being able to translate as well as a human can. Really, the key distinction being that a human can see the face and the hands and the expressions, and that helps them translate in a little more natural way. Speech. So one thing that one of our earlier speakers said was that a computer is starting to understand the world around them, right? So they can see things, they can hear things, and they can start to understand what that really means. So now 20% of mobile searches are done via voice. And you see this now with Google Home and Alexa and a whole host of other products. So it's an interface now, interaction. And again, all of these are trained on machine learning models. I love this one, sustainability, because so many of the examples that we use at Google are consumer products. Well, we build data centers, and we think we're pretty good at managing data centers. I think we spent $27 or $28 billion over the last 3 years on data centers. We're really, really good at managing the power, and it's a huge cost for us. So we said, well, if we're good at building these models to improve things like translation and speech and search, maybe we could apply this to how we run our own data centers. So sure enough, we took the data that we had on how our data centers are cooled, we ran a model against it, and over time, you could see when we turned it on, this is the ML control on, ML control off, we saved about 40% on the operation. And we thought we were pretty good at managing data centers. Smart reply. So I love this one because this was an April Fool's joke about 7 years ago where we came out and said, hey, Google's going to automatically reply to all your emails. You no longer need to even look at your inbox. Ha, 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 ha. Fast forward to last year, we actually rolled something out, again, based upon the context of the emails and the typical responses that come. We now make recommendations on what a reply might be. And this has been a huge success, much greater success than we thought. It says 12% of all replies now is from this system. It's actually more like 18 or 20. YouTube Watch Next. So YouTube, billions of hours of video, and really the key to engaging and keeping customers interested is the ability to, when they've watched a video or watched a couple of videos, to be able to show them relevant videos next and next and next and next. And once we applied a machine learning model on this, we're able to improve the long tail of the video watching. So it's not just everybody went from watching the X-Men trailer to watching, the next Avengers trailer. It was some people watch the X-Men trailer, and then the things that were on the far end of the tail of the videos, we were able to identify and make those recommendations. And so it engaged a lot of people who otherwise would have dropped off. All right, I'm giving you tons of examples here. This is one of the last ones, pedestrian detection. Now, I'm not tone deaf. I almost took this one out based upon events that happened yesterday over in the US. But I did want to keep it because there are, I think, 1.3 million deaths a year from automobiles, and about somewhere between 20 and 30 million people are injured a year. So this is a real significant problem. It's the safety of automobiles. And so pedestrian detection, the ability for a car, again, to see and understand the world around them, to be able to see that these are children dressed up in crazy Halloween costumes and know that that's something they need to stop and avoid and expect the unexpected from. And then the last example, again, was mentioned earlier today, Alphago. Alphago is, it's really a strategy. It's showing that a system can learn over and over and over again, improve itself, and develop strategies that are actually unexpected, that were shocking. I think that when Alphago played the champion in Korea a couple years ago now, Alphago made a move that was so stunning that Lee Sobel actually got up and walked out of the room and had to collect himself. He was shocked, and he couldn't believe that it was a machine that actually was doing this. And so systems that not just make right decisions, but make surprisingly right decisions. All right, this is a lot of examples. Now, in the last couple minutes, I just wanted to briefly say how this is done. All right, what's our approach to machine learning? So this is, again, a fundamental shift in how we develop, how we deliver services. 4,000 models deployed internally. This is a system that we've used internally. It's called Tensorflow. Again, a few speakers earlier mentioned this. Tensorflow has taken the world by storm. It's open source. Anybody can use it. My one point of advice for anybody who's relatively new in this space is go play with Tensorflow. Tensorflow is designed specifically not just for the data scientist, though it's great for data scientists. It's designed for the developer who wants to leverage machine learning. So it's designed for, the thousands of developers at Google and people like them, right? Developers. So not just some academic experiment. This is something that you can actually take and then deploy into, your own applications, your own services. So Tensorflow is taking the world by storm. This is just a quick snapshot of GitHub stars. You can see Tensorflow. It was open sourced in, I think, November of 2015. And it's really taken the world by storm. And there's a good reason for it. That would be my one key point of advice for you, if you have time. A good example, as we talk about how we do this, is, Tensorflow is open source, and it's as we say, it's a little bit of marketing stuff, but we're democratizing machine learning. We're making it available for anybody to use. And this is an example. There's a farmer. These are again all real-world examples. A farmer in Japan who last year, it was a small family farm. They had to manually sort cucumbers. This one's ready for market. This one's damaged, needs to be thrown away. This one needs to be, held a couple of days to make sure it's ripe. And so they split them up into 8 buckets. And it was time-consuming. It was difficult and painful. But it was a small farm, so they couldn't go out and buy really expensive automation equipment. And so what happened was, their son, right here, this guy standing in the middle in Japan, took Tensorflow, trained a model using transfer learning by taking pictures and putting labels on those pictures of cucumbers. And over a very short period of time, he developed a system that had a very simple conveyor belt, a camera, and then a little push arm. As you can see, I think it's up here, a little push arm that pushed it into one box or another. So Tensorflow really is fantastic. It really makes it possible for almost anybody who knows software development to implement machine learning in your systems. A couple of other things that we do at Google. So we have invested significantly in hardware, which is something that we've done for a long time but haven't talked about. So what do you need to be successful in machine learning? You need lots of compute. You need data, and you need algorithms. And you'll hear some flavor of that, I think, from everybody here today. So TPUs is optimized processing that's specifically optimized for the type of math you need to do for machine learning. So TensorFlow processing units are custom-built ASICs that we make available via our cloud. And then what we call the BF switch, which is just a really, really big freaking switch. And our network is lightning fast, which is really important when you need to do parallel computation of very large data sets for training. So TPUs versus conventional, it's really, really fast. And ultimately what it comes down to is reducing the cost of doing this, right? Lots of compute, lots of data, and great algorithms. And driving down the cost of doing training, which is typically really expensive, is something that everyone is driving towards. Cloud makes it possible. Custom-built ASICs make it possible. Really fast networking make it possible. All right, and then really the last thing I want to touch on, I didn't want to come here and give you a product pitch in only 15 minutes, but I did want to talk about the portfolio that we develop. We've got what's up here called perception services. These are pre-trained APIs that if you know nothing about machine learning, but you still want to take advantage of machine learning, you can do that through things like vision and speech and understanding of text, translation. All you really need to do is a few lines of code. You can call an API and build that into your applications. We've got platforms, libraries, and tools. And you can see across here we've got Tensorflow that falls in there. And that's open source. Again, you can run it on any cloud. You can run it on-prem. We also have something called Cloud Machine Learning Engine, CMLE. That's really the core cloud offering that we have that lets you take the Tensorflow model that you've built maybe on your own Python notebook at home and train it at scale on our cloud and let you do things like hyperparameter tune, and so that you can more quickly have effective models. And then the last thing I mentioned down here is the AI infrastructure. So we have compute, we've got GPUs available for you, we've got TPUs, again, this great networking, and then cloud storage. So this is basically our core portfolio on what we offer and what we help customers with, how we do ML. The newest additions, which if I had more time, I'd love to talk about, Dialog Flow Enterprise Edition. This is a system that allows you to build chatbots. AutoML is a whole new approach to taking these pre-trained canned APIs and letting you train them yourself on your own data, your own images is what's available today, AutoML Vision. So we've got a broad portfolio. Tensorflow is really at the heart of how we do machine learning. We've got Cloud Machine Learning Engine, again, for you to build those custom models, to train them at scale. So you don't need to build and manage your own hardware and clusters. And then finally, we've got these perception services that anybody can go out and use. So if I were to close, I would just say, machine learning is a lot of hype associated with it. Google's in a unique position because, as one of our earlier speakers said, we have a lot of data, and we've had a lot of people who've been thinking about how to leverage this because we've had to. We've had to in order to change the way, again, change the paradigm on how software is developed and delivered to customers. So one last thing before I leave, I'd like the Google folks who are here, because we don't have a booth, could you stand up and wave? Whoever's here, wave, wave. We got 3, 4, 5 people. So track them down, another one up here. Track them down because we don't have a booth, and I'll be around the rest of the day. All right, thank you.
Thank you. All right, I'll take that. I'll take that. Perfect. Thank you so much, Dave. Looking forward to our cup of coffee in California. Oh, you can take that. Excellent. Could you do something about the kosher food in California, by the way? Please do.